Hello 108 students, welcome to section 5.5. Mr. McHugh here with you. Going to tackle page 1 on this video, and what we're going to focus on here is dividing polynomials. Okay, so polynomial, we like to write them in fraction form here. Example 1a, you will have a polynomial up in the numerator and you'll have a monomial in the denominator. Now, as long as you're dividing by a monomial, these problems are basically a piece of cake. And all they're asking you to do here is take each term up in the numerator and divide it by the single term in the denominator. Now you could separate them out if you like here, as I've done here in this example. So if you'd like to do that, that's fine. A lot of you might be able to just look at 15x squared divided by 3 and say 3 goes into 15 5 times, and notice the x squared comes along. This one's fairly easy. Negative 12 divided by 3, I've got it written out here. Result is negative 4x. Finally, 6 divided by 3 is 2. And you're on your way. Here's another example here, a little more realistic, where you've got a trinomial divided by still a monomial or a single term. This time it's 5x squared. Okay, I took the time to separate them out on the numerator. Each term in the numerator gets divided by the denominator, and next you have 5 divided by 5, negative 9 divided by 5. The m squareds cancel out, and finally 10 divided by 5 is 2, and m to the first, and you can see the work over here. 1 minus 2 is negative 1. Flip it down to the other half, and you've got 2 divided by m up here in your first guy. Okay, so there you're doing good. Then we hit the situation of example 2, and if you look on your book on page 303, I did not write it on my class notes, but I think it's kind of important for you to see this so you understand why and when you use long division. Okay, so what you have here is this problem. I'm going to try to squeeze it up here. This is number 2, and here's what it looks like in the book. Up in the numerator you have 2m squared plus m minus 10, all divided by the denominator has got m minus 2. Now that's how the problem looks, and it looks almost similar like the first examples up here, except what's the big difference here? Check the denominator. How many terms do you have? When you see it's more than a monomial or a single term, aka it's a binomial or trinomial, then you have to go to long division. Okay, that read is right here, and realize this is bigger than one term, and so you've got to go to long division. When you go by long division, the numerator becomes the dividend, and the denominator becomes the divisor. D-I-V-I-S-A-R. I always remember the divisor is that's what's going into. That's the action one. Okay, in case you ever had troubles with that. Okay, so you must set up long division. Now, these problems here, let me move down a little bit here. Explaining these on the board, when I first did it, there's a lot of wordy explanations. I call this side work over here. You don't have to do all this. You just got to try to get the sequence or the process down. It's very mechanical. You have to watch the details. There's a lot of booby traps on these things. If you make mistakes with them, they could drive you a little crazy. Okay, so bear with me, and I'll try to take a couple minutes here and go through the process once. Okay, first step, don't forget, you realize the problem you're dividing by a binomial or greater, convert to long division. Okay, now to start this process, you take the first term in the dividend, 2m squared, and you divide it by m. 2m squared divided by m. Okay, now that's how this goes. Now when you start that process, what's the result? 2m squared divided by m. Now here's the deal. You see I circled that with an m? That first term in the divisor is what you're always going to divide by. I'm just hoping you could see that pattern. So 2m squared divided by m, the result is 2m. That result is part of your quotient, and you take it and you stick it up on top of where the quotient goes, and you line it up under like columns. That's all you got to remember, like columns. Other thing I forgot to mention here, look at the exponents. Are they in descending order? M squared, m to the first, and a constant. Yes. M minus 2, they are in descending orders. Both the dividend and the divisor must be in descending order. If you do not see that, you put a placeholder in, and we'll do that on the second page. Okay, except for that requirement, this process I'm showing you doesn't change. Okay, so let's go back to our idea. We figured out the first quotient. Now, just like you do long division back when you're in 4th grade, you now take that quotient, you multiply now by the entire divisor, m minus 2. So over here, I took the quotient, I brought it down, and I multiplied it by parentheses the entire divisor. Hopefully you're seeing that. The 2m came from the result, so I brought it down, and I multiplied it by the divisor. Okay, now what's this result? 2m times m is what? 2m squared. 2m times minus 2 is minus 4m. Okay, now hopefully everybody's okay with the multiplication. You bring it down. Now the deal is these parentheses tell you you're going to subtract. Okay, now a couple things. If you can correctly take 1m minus 4m and come up with positive 5m, and then negative 10 minus 0 is negative 10, you're on your way. Some students like to convert these to additions, and so I do it also. It really gets crazy to explain it on the whiteboard, and you're doing it here in these talking class notes. It'll get a little crazy. So subtract the columns is the official way. If you like to convert from subtraction to a division by changing the signs, go for it. Okay, now as soon as you do that, you've completed a cycle. The result is 1 minus a minus 4 is a positive 5m minus 10. Now you start the cycle all over again. Take this new leading term, bring it down, and divide it by the first term of the divisor, aka circle m. So you get 5m divided by m. The result is 5. Take it and place it up in the quotient under the like columns, therefore the constant. Okay, now what do you do with that? Then you take the quotient and you multiply it by the entire divisor, m minus 2. Now here's my work. 5, which was the quotient, multiplied it by the entire divisor, m minus 2. So here you go. 5 times m, 5m. 5 minus 2 is negative 10m. Excuse me, negative 10. Subtract the columns. 5 minus 5 is 0. Negative 10 minus a minus 10 turns out to be 0, and we have no remainder. And this is your answer, 2m plus 5. Okay, a couple cautions. Be neat, be organized. Watch the subtractions when you do here. If you make a mistake here, you're toast, and from here on in you're spinning your wheels getting the wrong answers. Okay. What happens if you end up with like a 1 here? Let's just pretend. What if this would have been a 1? Just like when you did long division, you take that remainder and you'd say plus 1 divided by the entire divisor, m minus 2. That would have been the example for that. Okay. They take a little bit of practice. You got to be neat, you got to be organized, and try to keep your patience with you. Okay. Now, notation wise, we're talking about polynomial functions now. So instead of just giving you a bunch of terms out there, they're now going to group them. They now are going to say, what if you have f of x is up in the numerator, g of x is down in the denominator. This should be a g right here. You could write that in notation side by parentheses, f divided by g of x. Again, there's not multiplication. That tells you that's the variable. Relative to the variable x, what's the division of the two polynomials? Okay, now in this example here, instead of using m, they used x, but it's the exact same problem. 2m squared plus m minus 10. They changed the x to m's to x's, and I'm not going to work out all the results here. So what they have you do here is do the long division and get your final answer of 2x plus 5. And we just did all the nitty-gritty work up here. Okay, now then once you know what the result of that division is, they will give you a specific value for x, -3. Plug it into the result, the quotient of that function, dividing of those two functions. Take 2 times -3 is what? -6 plus 1. Final answer, -5. Okay, so that was a little long. I'll be back on page 2. We'll do one more of these, and hopefully you'll get comfortable with that process. Okay, Mr. McHugh, saying goodbye for now, and I'll see you for page 2. Okay, bye.